everybody, welcome again to the Extractive Metallurgy course. Today we are going to have the class number 9. We are going to develop the most important process in the hydrometallurgical processing. The first process we are going to present is leaching process, and the second is the precipitation process. Today, first, we are going to present the leaching process, and the idea is to what it means the leaching process. When you are working in hydrometallurgy, you are going to develop to extract the mineral that exists in a solid, mix it with the liquid, as we defined in the last class. We are going to have a reaction between solid and liquid. The mineral is in the solid, and we are going to use a liquid, a solvent, in order to extract the liquid, the solid, sorry. And the idea is to extract the solid using the liquid. That process is called leaching. Leaching is the process to extract something from solid using a liquid, dissolving the solid in the liquid. And the idea is to obtain a solution. A solution is the mineral solved in the liquid. This is the characteristic of that we are going to present in the leaching process. Sometimes it's not possible to extract directly the mineral or using hydrometallurgical processes because the solid maybe don't react with the liquid. That's why sometimes it's necessary to transform this process. As we studied in the last class, we defined that some solids have covalent bonds. When you have covalent bonds, it's not easy to use a solvent in order to extract the solid, because the solid don't work. The solid don't dissolve in the liquid. That's why sometimes it's necessary to use special pre-treatment, as roasting, as reduction, minerals or pre-treatments that could be change the characteristics of the solid in order to be solved in the liquid. Okay? In order to study the leaching processes, it's necessary to study the leaching agents. Which are the leaching agents in order to work, in order to develop the hydrometallurgical process? The most important is selectivity. That the agent we are going to use works as a solvent to the solid. Okay, this is important. The other important thing is the cost. Okay, because it's necessary to use a non-expensive agent to make the reaction, and of course to work to select a leaching agent that works, that really have the reaction and could be have the possibility to react effectively with the liquid, with the solid. Okay, it's possible. And of course, have the possibility that you can reuse the agent when you extract the solid, the mineral from the solid, be in solution, then you precipitate the metal of interest, and then reuse the liquid or the agent for another reaction. Okay? Which are the different leaching methods that exist? The objective is to, in the field, in the mining operation, it's important to define or to achieve the maximum economic benefits of the processing with low cost and high efficiencies. And of course, there are different factors that could be possible and facilitate the work, facilitate the action in order to obtain it. It depends on the concentration of the reagents, it's important, the form of the reaction, the leaching methods, there exist different kind of methods we are going to study, some variables, thermodynamic variables that affect the process, like temperature, pressure, or time, or concentration of the agents. It could be important to take into account. Now, I'm going to show you different kind of methods that exist in order to react, in order to make the leaching process. The first, or the most easy, the less complex method is the in situ leaching. In situ leaching could be is a very common method in order to obtain, for instance, uranium, copper, or some special metals. It is really easy to obtain. You have to make a hole in order to prepare the field. The ore in the terrain has to be in the conditions that could be possible to make a drill, inject the reagent, and make the solution and the reaction between the reagent and the solid, and then you extract the solution and go to the processing plant. This is the in situ leaching. Of course, you need some special condition of the ground in order that could be possible to the reagent enter to the soil, to the rock, and make the reaction. Exists another possibility in the in situ leaching is the forced in situ leaching. In the forced in situ leaching, the difference is you have two drills or different drills. Some of the drills are for inject the reagent, and the other drills are for the extract the reagent. In the simple in situ leaching, you only have one drill to inject the reagent, and in the same hole you extract the reagent or the solution. In this forced in situ leaching, you have some drilling for the inject the reagent and another drilling in order to extract the solution. And then you extract the solution and go to the processing plant. This is a very common method used in the uranium extraction nowadays. It's important that you need some special conditions in order to could use this this method, because it's very easy, really, relatively, but you need the conditions to do it. Okay? For instance, as you see in the picture, could be it's necessary that the body, the ore, has the possibility to react with the material, because the reagent moves through the ground and move through the ground in order to have the reaction in situ. Another kind of method is the leaching in tailings, in dams. It's a very relatively common when you have some special kind of ores, or you have a low mineral with very low concentration. You could use this kind of method in order to create conditions to leach the ore that in the tailings in order to extract the effluents and then go to the processing plant. And the other is create some piles to extract the mineral and put the piles or create the piles, and then inject the reagent in the piles directly. By percolation, the reagent pass through the piles, and then you obtain the minerals, obtain the effluent, and go to the processing plant. It's a common. There are some pictures that could be easy to understand and to use because these minerals, these metals, these leaching methods, they are very common when you have the conditions. But it's important to create a pool, create a place in order to obtain the leaching or the solution before to go to the mineral process, the processing plant. This is some pictures from some operations that work in this way. These are some different activities that you have. Okay, this is the last methods in situ leaching, tailing, or piles are used in the field. But you can use some special tanks. The first of these methods are the percolation leaching. The percolation is a very old method. It's not very efficient. The efficiency is very low, really. The idea is to put the mineral in the tank, and then you put the percolation leaching, and then you have a special batch material, and the reagent cross the floor of the tank, and then you recover the solution. But it's not very efficient. Also, a very similar method is the ponds leaching. The pond leaching is similar to the percolation leaching. You have a mineral, the solid, and you put the liquid in the mineral, and then after a time you obtain the mineral in the bottom of the tank. But the real common, the more common method is the agitation leaching. You have a tank with agitation. Is the difference with the another precipitation and the percolation or percolation leaching or the pond leaching, because you don't have the possibility to move the material. In the agitation leaching, you move the material, you move the solution, and have the possibility that the reaction could be more efficient, have more efficiency. In the agitator, you have the possibility to change the shape of the agitator, or to change the shape, the position of the agitator, or to create different kind of the bottom of the tank. It's possible to have different options, different possibilities. And the idea is to avoid places or points that the materials don't move. It is to move the material, it is to move the solution, and to have the possibility that the material have more efficiency in the extraction of the mineral with the liquid. This is one of the things we have to define. Another thing is to put some baffles, to obstacles in the tank in order to avoid the mineral to be deposited in one place in the tank, the bottom of the tank. Okay, there are some pictures about some agitation tanks. It's very common. For instance, for salinization process, it's very common. And the other is Pachuca tanks. Pachuca tanks. The difference between Pachuca tanks and the traditional tanks is the relationship between the diameter and the height of the tank. In these Pachuca tanks, the Pachuca tanks are very small in the diameter and very high and very high tanks. This is the difference. These kind of tanks are different because they have more efficiency in order to have a better mixture between the mineral and the liquid. Okay? There are different kinds of material Pachuca tanks. You can inject oxygen in order to help to the solution and to help to the reaction between the solid and the liquid. Okay. This is a typical salinization circuit where you use agitation and you use thickers in order to have more efficiency in the process. Okay. The second process that is important to work in this in the hydrometallurgical process is the precipitation process. Okay, the first part is you have the mineral and you have a interest, mineral of interest in the solid, and you are going to use the liquid in order to extract the liquid from the solid, and in this moment you have a solution. In this moment you have a solution with the mineral salt inside. The name is the liquid. You have a liquid, yes? And as a result, you have a solid that in this moment are the wastes. We have the responsibility to take care not only of the liquid, because the liquid is the solution. The liquid is the most important part because it's the solution, it's the metal inside. But you have the obligation to dispose adequately the solid. The solid in this moment are the tailings, because in this moment you extract all the interest or the mineral of interest of the solid. This solid in this moment is the wastes. You have to make a very good disposition of the wastes in order to avoid environmental problems. Okay, you have to be responsible with these wastes. Okay, you have to dispose in the best condition, or maybe to create conditions in order to make circular economy or to use the wastes in another processing. It depends on you. But it's important to take care or to have the responsibility to work with the wastes. Okay? This is the first line, the wastes. The solid are now the wastes. And now we are put our attention in the liquid, in the solution, in the liquid. The solution in this moment is important to create conditions or to purify the situation, okay? To avoid the presence of some characteristics or some contaminants or some particles that are not of interest, okay? But your focus, your attention is in the liquid. And now we have to precipitate the metal of interest or the mineral of interest. For instance, if you are going to a salinization process with gold, you extract the gold of the rock. You have the rock as the wastes. For instance, the sulfurs. You have the sulfides. You have the sulfides. And now are the wastes. You put the wastes in a special disposition, and you obtain the gold. The gold is now in the solution. It's an channel. My role now is to precipitate the gold in order to obtain the gold again solid and to have the liquid separate. Okay, this is the moment. Before to start the precipitation process, you have to clarify the situation, avoid the presence of some contaminants, and make cementation. Cementation is another word to refers to precipitation. Okay. When you are going to do the precipitation, you have to define what are the methods you are to use. Because you could use another metal in order to precipitate your metal of interest. The name is cementation. Or you could use a special, maybe a special electrostatic processing, use electricity, or use another solution in order to precipitate the material you want to work. The more common method is cementation. Cementation is a process that you have your mineral of interest, is the metal number 1 first, for instance, and you use another metal. Okay, your metal of interest is in solution, and you use another metal number 2 in order to make an interchange of electrons. Metal number 1 is your interest. When you put the metal number 1 in solution in presence of another metal, maybe you make an interchange of electrons, and now your metal of interest are in solid conditions. This is the precipitation. And the metal number 2 goes to the solution. This is the cementation process, and very important to take into account. When you are working with the cyanide in order to obtain gold, for instance, you can use zinc. as a metal. Yes, your metal of interest is gold, but you can use zinc. Yes, when you use zinc, there exists precipitation, and the gold precipitates and now is solid, and zinc goes to the cyanide solution and is now in solution, is now liquid. This is the cementation process that is important to develop. Okay. Sometimes it's not easy, maybe it's not evident, some reactions are not evident, some reactions could be difficult, and the idea is to work in the best thermodynamic conditions in order to create a very good precipitation. Okay? Sometimes it's not a good idea to have oxygen in the reaction. For instance, when you are working with gold, using cyanide, you put a cementation process with zinc, you have to avoid the use of the presence of oxygen. In that sense, it's necessary to avoid the use of oxygen, because oxygen could stop the reactions. And in that case, it's important to define in which moment you are going to use or to avoid the presence of oxygen. When it's important to define which are the reactions, which are the reactives that interacting in the reaction, because oxygen could be a problem and it's necessary to avoid. Okay. In cyanidation, when you are making the precipitation with zinc, the process is important to do it in vacuum without oxygen, and this process is named Merrill-Crowe. Merrill-Crowe is a very important process that is very common, and you avoid the presence of oxygen. Okay. When you are making the precipitation, it's important to define the characteristics of the zinc, the concentration of the zinc, the concentration of gold, maybe silver, but because it's important, it's very common that they are there, and how to define the potential and pH of the solution in order to define which are the best equilibrium zone, equilibrium phase, in order to define the electric condition and pH condition that is necessary to work here. Okay? Okay. Sometimes it's not it's necessary to define the quantity of reactives in order to guarantee that the efficiency of the reaction is improving. The idea is to create the conditions for the material. Okay. In that sense, when you use this processing, for instance, if you are gold cementation with zinc, you define the characteristics of the material in order to avoid the presence of elements that could stop the reaction. Okay. Here we have some flow sheet of the cementation of the gold with zinc. It's important to have the characteristics, or it's important to have the gold, where is the vacuum tower, to avoid the presence of oxygen, and to increase the behavior of the zinc to obtain the gold. Okay. Sometimes in gold, it's very common to use activated carbon. Activated carbon is an alternative to the zinc, because sometimes it's easy, sometimes the efficiency of the reaction is higher, and you don't have to use another metal. You use activated carbon because they could work in a better way. But the principle of the reaction is the same. You are going to separate, and you are going to replace one metal for another metal, or one metal for another chemical species, and then try to recover the gold you are going to use. Carbon, activated carbon is very common and every day are used for more people in different companies. But it depends on the tradition, it depends on the technology, it depends on the possibility to obtain. Okay? Okay, what happened in the environmental topics? We were during the leaching, you obtain the wastes and you put the wastes, you dispose the wastes in a very good, you have to dispose the wastes in a good condition. What happened with the liquid? Okay, you have the solution, you precipitate the metal, maybe gold or another metal, and then you have the solution. It's important that define which are the methods to clarify the situation, or to reuse the solution, and to return the solution to the flow or the processing plant. And it's important to define that kind of things. In this moment, always you as a metallurgist or engineer or the plant or the processing plant, your responsibility is not only the metal of interest. It's very important, but you as a professor, as a professional, you have to dispose, make a very good disposition of the wasted, solid wastes, and of course the effluents, the liquids that you are going to use again, or maybe you have to dispose in the rivers or in the lake or in a place. You have to do it in the best environmental conditions. It's your obligation. You have to do it in the world. One of the topics is how to degradation of cyanide. When you have a cyanide solution, you have to degrade the cyanide in order to avoid the bad consequences of the cyanide. Exists some different possibilities, different methods to degrade the cyanide, and the most common, method is using peroxide. Maybe hydrogen peroxide is very common. You have the cyanide, and you use hydrogen peroxide, and as a consequence of this reaction, you obtain cyanide. Now, cyanide, you oxide the cyanide. It's the most important consequence. And when you oxide the cyanide, you have a salt, and this salt is inert. As it's inert, you don't have the possibility to create contamination in the water. It's fundamental avoid the contamination of the water. This is the first method. Exists different methods. Another method is the Canstone process. The Canstone process is similar. You use hydrogen peroxide, of course, but at the same time you use formaldehyde and copper. It's a commercial process. But the most important is to oxide, make an oxidation of the cyanide. The other method is the USA Corporation method. The USA Corporation is a commercial method. The idea is to use again hydrogen peroxide, but you use copper sulfate, because the copper sulfate helps in the oxidation process. Okay. Another is the chlorination and oxidation alkaline. When you make the chlorination, similar. The idea is to create a reaction with the cyanide in order to avoid that the cyanide reacts with the water and contaminate the water. Exists the possibility to have another very common is the Caro acid. The Caro acid is a peroxymonosulfuric acid oxidation. This is the complete name of the reaction. you have to prepare this kind of acid. This acid is prepared with sulfuric acid, with hydrogen peroxide, and you take this kind of decaro acid. Decaro acid is a very high oxidant agent in order to transform the cyanide. In this way, you transform the cyanide and have a new product that is no contaminated. They don't contaminate and don't have the possibility to react or make some reaction that could be difficult. Okay, this is the final actions, the final points that I was interested to present to you in this class. Today, as I presume, we work in two different processes, the leaching processing and the precipitation processing. This is the most important process in hydrometallurgy, in different materials, in different metals, in different characteristics of minerals that we are going to work. When you control the solid and you control the liquid, you could make different characteristics of the metals and in order to leach the product and then to precipitate. And remember, it's very important to control all the products, all the lines in the reaction, the tailings, the effluents, and of course your mineral of interest. It's the most important in a hydrometallurgical process, in general in extractive metallurgical process. Thank you very much for your attention. Thank you for assist to this class, and I hope you enjoy this class. See you in the next lesson. Thank you very much. Have a good day. Bye bye.